Welcome back, geometry students. We are working on the second day of Standard 1 today, which should be in Class 4. If you'd like to find that notes page, the goal would be for you to follow along as we talk through these ideas. We're going to be extending the idea of segment addition postulate and the definition of midpoint that we introduced in class previously. In fact, the intro section has problems very similar to what you're used to from yesterday. So I'm going to have you pause the video here in a minute. Your goal for each one of these 4 problems is going to be to use the information provided, but to find the missing segment length that they ask you for, as well as to practice writing those general equations and reasons in the blanks. So go ahead and pause now, and when you feel like you have that taken care of, come back and you'll be able to check your understanding from yesterday. All right, welcome back. As you can see, I have taken information from each of these problems and done a little bit of labeling, which I think is always a good strategy as you get started. This problem asks us to find the length of segment MN, right there marked with those 3 question marks, if the length of segment LN is 62. So I just showed that that distance all the way across that segment was 62. There's no mention of a midpoint, so hopefully for this first one, you went with a segment addition postulate setup, where the 2 smaller parts of the segment add together to be equal to the entire thing. If we go ahead and plug in our values, that means we're going to end up subtracting 18 from 62 to get that the length of MN as a segment is 44. For question B, we do have a midpoint, so that means we're able to show that these 2 parts of the segment are the same size, but unfortunately, they're not asking us to find the length of segment DE. We were focused on CE. So I marked this entire segment from C to E with those question marks. So if we're trying to find a relationship between what we know, CD, and what we want to know using the idea of a midpoint, that would look like this. CD, this part, is half of CE, thanks to the definition of midpoint. And so when we plug in our values, that means 12 is half of CE. You can get rid of that half if you're using algebra by multiplying by 2. Hopefully it makes sense that it takes 2 of those segments together to make up that entire CE distance. So 24 should be your answer for the length of CE. Part C is very similar. We've got a midpoint again, point G. This one flips it a little bit and tells us the length of the entire segment FH is 56. They want us to track down the length of FG, so we can write a very similar general equation. FG is the part. That's going to be equal to half of the whole segment, thanks to the definition of midpoint. And so FG is half of 56, or 28. Now, question D seems a little bit different, but we have a midpoint. O is the midpoint of MN. So that means that this segment between M and O is the same length as the one between N and O. And since they're asking us to find the length of segment ON, that's really all we need. MO and ON are equal. So that would be our general equation. That's thanks again to the definition of midpoint. And since we have that value sitting there as 9, we can just say that 9 is what segment ON is equal to. So that extra little portion there with the 13 doesn't even end up being important. Hopefully those went okay. If you struggled with those, then you might want to come into RTI and get a little bit of help with our day 1 material. But otherwise, we are moving forward to work on the idea of midpoints a little bit more today, as well as segment addition postulate too. All right, down below, we are looking at situations where we've been given a midpoint. So G is the midpoint of segment FH. That means that this segment FG is congruent or the same size as segment GH. And then we have another piece of information here that FH, the whole thing, is equal to 50. Okay, so I'm just going to underline that. 50. Our goal is to find the value of x. And so there are a couple of different ways that we can do these problems, but it's very important that you're showing your work in a way that's consistent. So the first way is to think about the fact that we just said these 2 segments should be the same length. That means we would be able to take this 3x plus 4 and we would be able to label the length of segment GH in that exact same way. Now, we can't just go about doing that without having a reason, especially since we're going to have general equations and reasons as part of our work again. So if you do that, you need to explain where that came from, even though there's not an answer blank for that. That actually came from the fact that we understand the definition of midpoint. If you didn't know what it meant for G to be the midpoint of segment FH, there's no way you would be able to move that 3x plus 4 onto the other half of that segment. Now that we have all three of these values, we know the two parts of the segment and we know the whole thing, we're able to actually write a segment addition equation even though we've been given a midpoint. So the two small portions of the segment, FG plus GH, are going to combine together to make that whole segment. So what we're really using as the reason for our general equation is that segment addition postulate. But the definition of midpoint helps us out along the way. So if we go ahead and substitute our values in, FG is equal to 3x plus 4, plus GH is also 3x plus 4, and together they make FH, which is 50. If we do some algebra, combine those two like terms, same thing here with these two constants, we end up with 6x plus 8 equal to 50, and then you can go ahead and finish out that solving. Now, as I mentioned at the beginning, that is only one way to track down the value of x. So we're actually going to do this problem a second time and show you another option, which is very similar to example B and example C up above. So if those were a little bit confusing for you when I used this 1/2 idea, you're going to be able to see that happening again in this example, but with some algebra involved. So if we only want to focus on what we know, which is this FG is equal to 3x plus 4, and FH is equal to this 50, we know that because G is the midpoint, this segment FG is half of this whole thing. So another option is for us to write our equation using that. FG is half of FH. If you don't like a half as a fraction, you could write it as a 0.5. That's true because of the definition of midpoint. So we're not using a segment addition setup here. We're just using the fact that we have a midpoint. The part of a segment when a midpoint is involved is always half of that entire distance. So when we substitute this time, FG is 3x plus 4, and that's going to be half of FH, which is 50. Well, half of 50 is pretty easy to calculate, so that just means 3x plus 4 equals 25, and then we can go about our equation solving just like we did on the other equation. We just have different values along the way, but they lead to the exact same answer. X is equal to 7. So we've got some flexibility when we have midpoints. If we're concerned with a problem where we have a part of the segment and the whole thing, you've got some options about how you handle it. But if you use this option number 1, you must label on your picture and show why. So this definition of midpoint reason has to kind of be hovering here to go along with all of your segment addition postulate work. All right, that takes us through levels 1, 2, and 3, I believe, on our scale. So we're going to move now into what some of our level 4 questions will look like. Now don't tune out, because just because it's level 4 doesn't mean it's impossible. It's actually very manageable if you've understood what we've talked about so far. We already know that parts of a segment can be added together to find the length of the whole segment. Test yourself. What's that called? Parts of a segment can be added together to find the length of the whole segment. That would be the segment addition postulate part we've been working on. And then we also know that a midpoint divides a segment into two equal, or some of your teachers might have used the word congruent, parts. So we're going to combine those two ideas together. So reading very carefully, O is the midpoint of segment MN. O is the midpoint just of this segment, MN. So we're not talking about what's happening over here between M and L. That means that these two portions have to be exactly the same size. That's our definition of midpoint. So we could take this 15, we could move it over here. If we were explaining our thinking, our reason, we would write definition of midpoint out here. I'm just going to abbreviate midpoint so that it fits. And then we have another piece of information that tells us that ln, so that's all the way along this segment, is 51. And our goal is to find the length of segment LM, right there where those 3 question marks are. If you think about what's happened so far, we've used midpoint. We still have segment addition available. And in our example so far, the segment addition postulate has just been 2 segments adding up together to make a whole segment. But we can do that with as many parts as the segment is built into. This one is made out of 3 parts. So if I was writing a general equation, it would look like LM plus MO plus ON, all 3 combined together to make LN. And we're not being asked to write a general equation, so that's optional. We don't know LM, but we do know MO and ON are both 15, and we know that that whole segment LN has a length of 51. So we can go ahead and add those together and then subtract minus 30 from both sides. And we track down that LM is equal to 21. So very similar to what we're used to, just combining those 2 ideas together to make your way through that problem. Go ahead and flip the page, and I'll meet you there in just a moment. All right, we are now on the back side of in class 4. We're done with the learning part, and now this is just about solving, practicing, making sure you understand the ideas. So go ahead and look at example 5. This would be a good chance for you to pause and try the problem yourself before we go through it together. All right, let's see how you did. Point B is the midpoint of segment AC. So I'm going to go ahead and mark that AB is congruent to BC. If AC, okay, so the whole thing is equal to 5x plus 2, and AB is equal to 3x, our goal is to find the value of x. So this reminds me of what we did on the front side, where we can do this problem in 2 different ways. I'm going to choose to do this problem just with the definition of midpoint. So I'm going to avoid segment addition postulate, and I'm going to focus on just what the definition of midpoint tells me. And that is that AB, the segment that I know, is 1/2 of AC, the other one that I have information about. Now, you may have done this problem differently, so don't get rid of yours if yours is different. Just kind of hang tight and watch what happens as I solve. If we substitute our values, 3x is equal to 1/2 of 5x plus 2. Now, doing half of 5x plus 2 is a little trickier than doing half of 50 on the other side. So you have a choice. You can distribute that 1/2, multiply it by 5x, multiply it by 2. You will create some decimals, but as long as you're comfortable dealing with that, that's fine. The other option is to just get rid of this 1/2. You can do that by multiplying by the reciprocal. So I'm going to choose to multiply both sides by 2, which on that right side is just going to get rid of the 1/2 coefficient and leave me with the 5x plus 2. And then over here, 2 times 3x is just 6x. Lots of different options, though, in terms of how you solve that problem with algebra. 6x minus 5x is just 1x, so by the time we get that done, we have figured out what our x value is. Now, if your algebra looks completely different, but you got to x equals 2, you're probably okay. Just double check. We might want to double check in class that your general equation and that your reason match up with your work, but otherwise there are multiple ways of solving these problems. All right, go ahead and start the next example here. Go ahead and pause if you need to. This one has some more difficult algebra. We can see that look back to algebra to look forward to geometry symbol. So if you get stuck while you're solving, go ahead and restart that video and we'll help you out. All right, M is the midpoint again of segment LN. So we know this LM segment is going to have the same length as MN. ln, so this whole segment is 4x plus 6, and mn is x squared. Okay, so like I said before, this is a very similar setup to this one. We just see that we have a quadratic equation, so the algebra is going to be a little more complicated. I'm going to choose to do this one the other way that we talked about on the front side. So I'm going to take this x squared and I'm going to move it over here to be the length between L and M as well. Now remember, I need a reason for why that's true. So that's where we would draw our little arrow and call out that this is the definition of a midpoint. Now that the two parts and the whole thing are labeled, segment addition postulate is going to help me combine all that information together to get to an equation. Lm plus Mn equals Ln. Segment addition postulate. Now we need to substitute our values in and see if we remember how to solve these quadratics. So we did a little bit of review on these quadratics previously, but this one is a little tricky. X squared plus x squared gives us 2x squareds. And then remember, in order to solve these quadratics where x to the second and x to the first are present, we need the equation to equal 0. I'm going to keep this 2x squared positive, so subtracting 4x will move it over and subtracting 6 will move it over, so that everything is on the left side and can be equal to 0. Now I notice that all of these have a factor of 2 in common, so we can factor that out as a greatest common factor or divide both sides of the equation by 2. So what that does is it gives us x squared minus 2x minus 3. 0 divided by 2 is still just 0. And then you'll need to go through your factoring process. So whatever process you've used to figure out what these binomials are, you need to do that so that you can figure out what goes in these factors. If you're still struggling with that process, that's something to come and worry about with us during RTI probably. Now that that's factored, our zero product property tells us that either x minus 3 equals 0 or x plus 1 equals 0. So my x is going to equal positive 3 or negative 1 in algebra world. The question is, do both of those work? Sometimes in geometry they don't both work. So if we take 3 back and we plug it in, that would be 3 squared. So this segment is 9. 3 squared, this segment has a length of 9. 4 times 3 is 12, plus 6 is 18. So that works. 9 plus 9 is 18. So this is for sure a valid answer. Negative 1 squared is positive 1. Negative 1 times negative 1, which makes this segment also positive 1. 4 times negative 1 is negative 4, plus 6 is positive 2. So that one also works. 1 plus 1 is 2. So in this case, both of these are valid geometric answers. X equals negative 1 or x equals 3. All right, there are 2 examples left that kind of target to the same idea. Go ahead and pause and see what you can do with this next one. Okay, I chose to do this example in the same way as I did the one directly above it. So AB is equal to half the length of AC. I did the same algebraic process of multiplying both sides of the equation by 2, and I got to the point then where x is equal to 18. This problem does something the others have not. They ask us to make sure that we actually find some values, specifically for this one, the length of AB and the length of AC. So if we go back and we look at AB, that's supposed to be x plus 1, but that's not a very specific answer. So we're going to take our 18 and go ahead and add it in. So AB is actually equal to 19. We can do the same thing with AC. 3x will be replaced with 18 minus 16, and then we can calculate what 3 times 18 minus 16 is equal to, and that value turns out to be 38. Now that checks out because 19 is half of 38, just like we set up the equation to be at the beginning. The remaining problems are actually examples of our level 4 questions where we have midpoint information, but also other information. Go ahead and try those. Bring those back to class. We will go through those and we will talk about them more. If you really want to hear all the details, you can keep watching, but otherwise, we'll see you in class tomorrow. All right, if you're sticking around to finish these out, F is the midpoint of segment DH. So these two segments are congruent, equal, they match. And LH is equal to 55. Since we're looking for FH, and we also have another piece missing that's equal to it, my suggestion would be to call that X so that we can also call this one X. They're not asking us for reasons or general equations here, so we don't have to explain how we came up with that, but that would be the definition of midpoint. And then if I shift into segment addition mode, adding up all these pieces, so X plus X is 2X plus 37 will give me that entire length from L to H, which is 55. And then we can go ahead and solve. 55 minus 37 would be 18. And if 2x is equal to 18, that means x is equal to 9. Now pay attention. FH is not x. So we need to look, well, actually in this case it is x, but that might not be the case later on. So FH, we labeled with an x, we solved for x, so we want to answer that FH is equal to 9. But if it had been equal to like x plus 1, like the last one or something like that, you'd want to plug that in. Moving on to example 9, dk, that whole distance from D to K is 34. F is the midpoint of segment DH, so FD and FH are the same length. They want us to find HK, so this is the goal, if FH is 2x plus 1, and HK, they actually give us information about it this time, is x plus 1. So the question is this little missing piece here, because we can't use 34 unless we have all three portions labeled. But my little tick marks make it easy for me to know that I need to grab that 2x plus 1 to label in that missing part. Shift over to segment addition postulate. We've got 2x plus 1 and another 2x plus 1 and a 1x plus 1 all combining together to be 34. If we combine all these like terms, we have 5x total and then a plus 3 total. And it looks like to me, we're going to end up with a fraction or a decimal for this one. They are asking us to find HK, so it's going to be a little bit easier probably if this is an exact decimal for us to write it in that format. So 33 divided by 5 is 6.6. We need to take that and plug it back in to find HK. So HK would be 6.6 plus 1, or 7.6 total. Last but not least, we've just got a couple of questions here to make sure that you're really thinking through what we know when we're told that a point is a midpoint of a segment. So if K is the midpoint of segment LM, so K is the midpoint of segment LM, is LK equal to KM? Yes, that is why we mark these with congruent tick marks. So that would be a true statement. Does it take 2 LMs to equal an LK? Well, LM is that entire segment. So would it make sense to have 2 of those equal to this smaller portion? Nope. We don't want 2 of a large thing equal to a small thing. That's a little bit backwards. What about this last piece here? Half of LM is equal to KM. That is true. That is exactly how we set up a couple of our problems today. All right, if you watched all the way through to the very end, you should be in pretty good shape for tomorrow. We'll see you back in class.